Okay, so we will be revising some of the index laws on this session. Now, these are the questions that I'll be covering. We start off with more, you could say, basic questions, just to make sure we're okay with our basic index laws. And then we will be we won't be looking at all the index laws. We won't be doing the last two that involve negative powers and the radical signs. So you see square roots. We'll be covering everything else, and it does get more challenging, and there are also challenge questions that I'll be doing. If you have a look at the challenge ones, they're more at a year 9, year 10 level, but if you understand the index laws, then you shouldn't have a problem doing the challenge ones, because you'll be using the same skills to do the more basic ones. Then you should be able to do the challenge ones. So try and have a go, because it's just as easy once you get the hang of it and keep practicing. All right, so we'll start with question 1. And if you have a look, we are simply multiplying variables and numbers, and also adding and subtracting. Okay, and just remember, when we multiply numbers or variables, that's where the powers will be changing. If we're adding or subtracting, okay, that's where the variables stay the same. We only add or subtract like terms. And what I say is you only add apples with apples and bananas with bananas. So just don't forget that. Okay, so we'll start with the first one. So these 3 questions involve the first index law, and that is whenever we multiply variables or numbers, all we have to do is add the powers of the same base, whether numbers or variables. And so with the first one, we can see we have the same number or the same base, and we can do this mentally. We can go 2 times 2 is 4, times 2 is 8, times 2 is 16. But the question did say to simplify, so using that index law, I know that if there is no power visible, there is an invisible power 1. And I'm going to show that I know that first index law by adding these powers. Now the base stays the same, but it's the power that changes. And we know that with the first index law, when we multiply, we add the powers of the same base. So we've got 1 plus 1 plus 1 plus 1, which is 2 to the power of 4. Okay, and I've simplified this. And if you wanted to, you could evaluate it. 2 to the power of 4, like we said, is simply 16. Okay, but I've shown that step that I've simplified. Now with B, we do the exact same thing. Imagine we had 2 times 2 times 2 times 2, but instead of 2, we have G. We don't know what G is, but it's the same base. So my base will be G. And if there's no power visible, the invisible power is 1. And the first index law, remember, multiplying, we add the powers of the same base. So 1 plus 1 plus 1 plus 1 is 4. And that's all I can do. I can't evaluate this, which means I can't find the actual number because I don't know what G is. Now down here, it's starting to look a little bit more complicated, but just remember, we do the exact same thing. Okay, we know in between every number and variable there is an invisible multiplication, so it's like having 2 times a times b squared times c to the power 4 and times, and the only multiplication sign is this one that's visible. So our final answer should have no multiplication signs visible. And the way to do this is, first of all, multiply your numbers as you normally would, because I know that 2 times 3 is 6, so I've done that. And if it helps, cross your numbers off once you've used them. Now, what you can do here is, because we're multiplying, our powers will be changing if we have the same bases on both sides. So what you can do is get your bases ready. So write all the variables or all the letters you see. We've got A, we've got a B and C and no other letters, so no other variables. Now that's your answer pretty much. Now all you got to do is add in the powers by adding them. So start with your A. Now there's no number here, so I know there's an invisible 1. Do I have an A on this side? Yes, so 1 plus 2 is 3, so I have A cubed. Cross it off if it helps. Next one, B. Do I have a B on this side? No B's on this side, so it just stays 2. And that's gone. And last of all, C. I've got 4 C's here and 1 C there. 4 plus 1 is 5. And that's your answer. So a trick is to first multiply your numbers and then write all your bases that will be in your answer, and then add the powers of the same base if you're multiplying them on either side. Now, question 2, if you have a look, we'll be simplifying, and we notice we have fractions in this. Down C and D, we're multiplying fractions together. Up here, they've already been multiplied, and we have to simply simplify them. So I've written the questions down so we can get started. Okay, so for the first one, if you have a look, it is quite of a basic one, simply simplifying a fraction. And by simplifying a fraction, we are taking out a common factor. So keep that in mind when we come to other ones like this. So 25 and 45, well, if you can't think of a higher, well, the factor that I think of is simply 5. The numbers both end in 5, so I can divide both by 5. So 25 divided by 5 is 5, 45 divided by 5 is 9, and we're done. Okay? And remember, by dividing by 5, we are actually taking out a factor of 5. So when I get to B, I notice I've got 25 and 45 here. So, oops, sorry, we do the same thing with our numbers. So I know I can simplify 25 and 45 to 5 and 9, because I just did it over here on that question. Now, we have variables, but remember, variables simply represent numbers. And I notice I've got 1x on top and 1 on the bottom. So that means I can take away 1 from the top and 1 from the bottom, and it's gone. And really, we have a 1 because we're actually taking out factors, which is like dividing, and we have a 1. Now I've got a B on top, no B's on the bottom, so my B stays on top. I've got a C on the bottom, no C's on the bottom, on top, so my C stays on the bottom. And that's your answer, okay? So you can only take away the smallest amount. So when we get to the other questions, you'll see what I mean by that. Now down here with C, we've got x over 10 times 10 over 8. Now this is using your basic fraction skills, and that is if we multiply two fractions, we can simplify anything from the top and anything from the bottom. That can be diagonal or that can be straight up and down, vertical. So if I have a look here, and we know we have to simplify before we multiply. I've got 10 and 10, 1 on the bottom, 1 on top. I can cross them off, divide them both by 10, they're just a 1. Done. I've got an 8 on the bottom, there's no more numbers on top that I can simplify 8 with. I've also got an x on top and no x's on the bottom that I can cancel out. So my answer will be x times 1 is x over 1 times 8 is 8. And just remember, when multiplying fractions, once you've simplified, you multiply numerators with each other, so x times that 1, and of course denominators with each other, so 1 times 8. And that's the answer. And on the bottom, D, so if you have a look at D, we don't have any variables, but it looks like a long question. But remember, all you have to do is simplify before you multiply, anything from the top and the bottom. So if I have a look at this, the first thing I see is two numbers are the same on top and bottom. So 100 and 100 are gone. Or we divide it by 100 and we get a 1. Now, it's up to you what you want to do next. You can do your 14 and you can do your 2. The one's on top, one's on the bottom. You can do your 6 and your 2. You can do your 3 and your 9. You can do your 3 and 6. So it's up to you what you want to do. I might just do my 14 and 2. I know that 2 divided by 2 is 1, and 14 divided by 2 is 7. Now I might do my 3 and 6. So 3 divided by 3 is 1, and 6 divided by 3 is 2. And if I have a look, I can't seem to see any more numbers. So now all I've got to do is go 25 times 1 times 1 times 1. I'll squeeze the answer down here, is equal to 25 over 1 times 7 is 7, 7 times 2 is 14, and 14 times 9 is 126. Just double check that. Yeah, 126. And that's our answer. Just double check 25 and 126. We can't simplify that any further. So that's our answer. Okay, so we'll move on to the next question. Now, question 3, if we have a look, we have to simplify these algebraic fractions, and it's simply by taking out factors. So I've got the questions here. So when you do this, start off with your numbers as normal fractions. I've got 42 on top and 6 on the bottom. So I know that a factor of 42 and 6 is 6. So divide by 6. I'll just change my color. 6 divided by 6 is 1. 42 divided by 6 is 7. And remember, your leftovers, if they're on top, they stay on top. I'll just write my 1 for now, and I can make it invisible later. Now, with the variables, You have to simplify only with the same bases. So I've got a Q on top and Q on the bottom, so that's okay. Now I've got 5 Q's on top and 4 Q's on the bottom. So I know that I go to my smallest amount, which is 4, and that is the maximum I can take out. I can't take out, for example, if I said I could take out 5 on the bottom and top, I can't do that. I've only got 4 on the bottom. So the trick is go to your smallest amount and take that away. 4 take away 4 we know is 0, okay? And anything to the power of 0 is 1, which is another way why it becomes a 1. But of course, what you do to the bottom, you must do to the top. So 5 take away 4, I'm left with Q to the power of 1, or just an invisible, it can be invisible. So on top, I've got a Q. Last one, R, I've got 4 R's on top and 1 on the bottom. My smallest amount is, of course, 1. So I take away 1 from the bottom and it's gone, it's become a 1. And R to the power of 4 take away 1, so 4 take away 1, I'm left with R to the power of 3, and that is on top. Now on the bottom, we know that in between everything there is multiplication, so 1 times 1 times 1 is simply going to be 1, and I've got that there already. And I know that that 1 can be invisible, so our final answer will be this, 7QR cubed. And remember that 1 on the bottom can be invisible. If we had a 1 on top, then it can't be invisible. Alright, so for B, we've got 12 and 36. The first thing I will simplify are my numbers. A factor of 12 and 36 is 12, so 12 divided by 12 is 1, 36 divided by 12 is 3, so I've got a third. Now I'll put my 1 there for now, just in case I end up with nothing on top, then it has to stay there. Now I've got 2 D's on top and 2 on the bottom. They're both the same, so just cross them off. Take away 2, and we're left with 1. I've got an E on the top, no E's on the bottom, so I will put the E there as a leftover. If I can't get rid of it, it stays there, but it's on top. I've got 3 F's on the bottom and 3 F's on the top and 2 on the bottom. My smallest amount is 2, so I can take away 2 F's and it's gone, or a 1. And 3 take away 2 is 1, so I have F to the power of 1, or just F. And that's my answer. And we can fix this up so that 1 can be invisible. And to make it look a little bit more neater, I have EF over 3. Okay, and that's it. Now, next question, with question 4, we'll be using you can say fourth or so index law, fourth and fifth index laws, where we now have brackets and powers outside the brackets. So this involves a different process, and we'll start off with 4a, which is a bit more the basic ones. And I've got the questions just here. Now, with 4a, this index law says if you have a power on the outside, you multiply this power with every other power in the brackets, including the h. The h has an invisible power 1. And that's a shortcut we can take, because just to recap on a few things, if I have 2 squared, okay, we know it's saying 2 times 2, which gives me 4, but that's what it's saying. So it's saying 2 squared is saying multiply whatever you have as the base twice. So if I have a look here, I have to have brackets because I've got, instead of one number or one variable as my base, I've got 2. For example, if I had just a g squared by itself, I don't actually need to have brackets. I could if I wanted to, but because there's one base, I'm simply saying g times g, which is g squared. Whereas here we've got g cubed and a h. That's why we must have brackets, because it's saying we're squaring both. Now, I'll just write this out. If we do this the long way, like the way we've just done it with the 2 and the g, we would have this. We're saying g cubed h times g cubed h. And we know how to do this. We multiply the same base, we add their powers. I've got a g as one base, I've got a h, and now add their powers. 3 plus 3 is 6, and 1 plus 1 is 2. Now, we can do it that way, and it is a bit longer doing it that way, but you have to be able to understand and show your teacher you know this index law. And once again, what happens if that 2 was just, say, 20 or 50? Are you going to write it out 50 times? No, it will take a little bit too long. So you have to actually know this index law and the shortcut. So the shorter way of getting that answer is to do this. Get your 2, and if it helps, circle it, do arrows, and an arrow there. Everything has to be multiplied and get a turn. and write this symbol, write times, to remind you we are not going to plus 3 to give us 5. Remember before we had 6, g to the power of 6, because 2 times 3 is 6. So we have g to the power of 6, and our h is 1 times 2, and it gives us, sorry, it's a funny 2, h squared. And that's what we got before when we did it the long way. Okay, so that's that index law. Whenever you see a power on the outside, circle it, do your arrows, and put that times. So this one down here, if we have a look, we have two different expressions or terms that we're working with. There's a times in the middle, separating them, that's fine. Eventually, we should end up with one, I say big blob, and where the multiplication becomes invisible. So work with one side at a time. All right, so I've got 2 times the 5 and 2 times the 3. So 5 times 2 I know is 10, so I've got x to the power of 10, and my c, I've got 3 times 2 is 6. Write that times down for now. Don't forget it, there's a times there. Now once again, do the same thing. I've got 3 times 2 and 3 times 2. I know 3 times 2 is 6, so I've got x to the power of 6, and 2 times 3 is 6 as well. Now we haven't actually finished. Our brackets are now gone. So remember, with BODMAS or BIDMAS, we have to work with our powers first and brackets, and we have done that. And now if we have a look, we simply have two terms being multiplied, and we know how to do this. All you're going to do is now add the powers of the same base. Remember, we no longer have to go 10 times 6 because we have no brackets. We only multiply when we see brackets. So now it's simply, get your bases ready. I've got an x on that side and that side. I've got a c, and they're my bases. And now we add the powers. 10 plus 6 is 16. 6 plus 6 is, hang on, it just froze. 6 plus 6 is 12. And that's our final answer. So this one involved 2 steps. One, get rid of your brackets by multiplying the power on the outside with every power on the inside. Okay, we've done that. 5 times 2 is 10, 3 times 2 is 6, and the same on this side. Now that our brackets are gone, we use the first index law we learned, and that is when you multiply numbers or bases that are the same, we add their powers. And we're done. So the one down here, if we have a look, we're doing the same thing. We've got brackets and a power that we have to work with on both sides, but have a look at the operation. It is not times, it is now plus. So this is where it'll be a bit different to what we did on the second part for question B. So first of all, let's start by getting rid of our powers. Now I'll just rub off this question so I have more room, and then I'll write it down again. All right. So with this one, we're going to have that 2, it's a power outside the bracket. So with that index law, we have to multiply every power is 1 there, 1 there, and 1 there. So 2 was to the power of 1. There was an invisible 1. 1 times 2 is 2. 3 times 2 is 6. 3 times 2 is 6. Plus, you can circle it if you want to, that times that, and that times that. And I'll put a times to remind me. 2 times 3 is 6, and 2 times 3 is 6. Okay, now that 2 squared, which is, if we have a number and a power and it's not too big, we can evaluate it. 2 to the power of 2 I know is 4. So I have 4, a to the power of 6 and c to the power of 6 plus a to the power of 6 and c to the power of 6. Now I just realized I forgot to do a couple of questions from question 1, but we can cover it here. If we have a look, because we're adding these 2 terms, we can only add them if they are exactly the same. And what I mean by that is, if I've got on this side a to the power of 6 and c to the power of 6, I must have a to the power of 6 and c to the power of 6 to add them. We are no longer multiplying, so the powers won't change. My answer has to have a to the power of 6 and c to the power of 6 in it. I can't change my powers. And if these 2 sides were different, we couldn't add them. That would be our answer. But because they're the same, and I know here there's an invisible 1, we simply add them. Like saying 4 apples plus 1 apple. 4 plus 1 is 5. And I have 5, a to the power of 6 and c to the power of 6. And that's it. Okay, so just keep that in mind. And at the end, I'll go back and finish the ones from question 1 that I skipped. I'll just write down the last question. So with this question, we do the same thing with our index law, a power on the outside. So this times every power on the inside. And remember, that 2 has a power 1 that's invisible. Be very careful. You don't forget that. So we'll have 1 times 2 is now 2 to the power of 2. You can write your bases first if you want to get them ready. 2 times 2 is 4 for our base A, and 3 times 2 is 6 for B. And of course we have times 3 here. Now please be careful, you can't just go 2 times 3 to give you 6 and then have 6 squared. That's a big mistake. Okay, we have to first evaluate our number 2. 2 to the power of 2 is not 2. I know 2 to the power of 2 is 4. Okay, so I've got 4, then A to the power of 4 and B to the power of 6 times 3. And now there are no variables on this side, so A to the power of 4 and B to the power of 6 will stay the same. But 4 times 3 is 12. And that is our final answer. Okay, our powers didn't change because there were no A's or B's on this side. Now, this question here, question 5, if you have a look, it involves the index law that anything to the power of 0 is 1. Okay, and if you remember we did an activity using a sheet of paper when folding to understand why anything to the power of 0 is 1. Okay, and basically it's because in real life we always have to start with something, and we can't not have something, otherwise we can't get anywhere, we have nothing. All right, so if you have a look, we're going to do question 5. If you have a look at the questions, a lot of powers that are 0, and we'll work with one thing at a time. Okay, so I've just got the questions here. So remember that index law states that anything to the power of 0 is 1. So with 5a, I see, look at my x, and it doesn't have an invisible power 1. The power that's visible is 0. And following the index law, I cross it, and it equals 1. And that's it. Because anything to the power of 0 is 1. All right, let's try this one. Now be careful, if you just wrote 1 as your answer, you've made a mistake. Because, yes, m is to the power of 0, but is 9 to the power of 0? No, 9 is to the power of 1. So 9 to the power of 1 just stays 9. M to the power of 0 is 1. And of course, we end up with 9 times 1. We know there's an invisible times there. And of course, 9 times 1 is just 9. So your answer for B should have been 9. Now this one here, it starts to get trickier because you see a power 0 outside these brackets. And we'll do this one the long way, and that is get your 0, and we know the index law, if you've got a power outside the brackets, you multiply every other power inside the brackets with that number. And we know 9 has a power 1, Z has a power 1, and I made them visible. And now we can get our bases ready, so 9 and Z, and we've got 0 times 1, which is 0. 0 times 1 for the Z is 0. And now if you have a look, they both have the power 0, and anything to the power of 0 is 1. So 9 to the power of 0 is 1, and I've got times in between them. Z to the power of 0 is 1, and 1 times 1 is just 1. So a trick is, if you have brackets and a power 0 on the outside, every single number in the brackets will end up being to the power of 0, so the whole thing will just be 1. So we could have just crossed off the whole bracket and the 0 and written 1. So for this one, for D, I'm going to skip doing it the long way. I can go 0 times 1 and 0 times 1, but I know that everything in the brackets will end up to the power of 0, so the whole thing will be 1. Now keep in mind, we have no number on the outside here, outside the bracket, so question F will be a little bit different, so keep that in mind. So far I've got 1, put your plus down. 2 to the power of 0 is just 1, so 1 plus 1, plus again, and I've got a 7 sitting there. And I'm sure you know how to calculate 1 plus 1 plus 7, which is 9. And that's your answer. E, I think E is the easiest one out of all of them because everything is in the brackets, power 0, cross it, it all equals 1. And we're done. And for F, now F would do the same thing. Everything in the brackets would have 3 times 0 and 2 times 0 and 1 times 0. It'll all be to the power of 0. So everything in the brackets will be to the power of 1. But that 2 is not inside the bracket, that's outside. So that 2 is just to the power of 1, so it's just a 2. So we really have 2 times 1, okay? So I know that 2 times 1 is simply 2. So this one, F, equal 2. And remember, it's because that 2 was not in the brackets, it was outside. Now for question 6, you can see 6a is similar to the questions we did before, and then we start looking at more algebraic fractions that we have to simplify, and we did a couple of these in question 2. So we'll be doing question 6. You can try them now before I do them, and I've got the first 3 written down. So 6a, once again, anything to the power of 0 is 1. So if you wanted to, that 4 is not to the power of 0, it's to the power of 1. So it's going to be a 4. But L to the power of 0 is a 1. And this one here, everything's in the brackets, the power 0. The trick is, it's all going to equal 1. So I now have 4. So it's just a 4 times 1. There's a times there. Times 1. And 4 times 1 times 1 is just 4. And that's our answer. Now 4b, this is where we start getting fractions again. And we can see there is a multiplication sign that's visible. But just remember, it is like having, for this one, it's like we have this. X squared b cubed, x cubed b squared. What have I made invisible? I've made the times invisible, okay? That could actually be invisible. And we do the exact same thing as we did previously, and that is simplify before you multiply. Okay, so 2x is on top, 3 in the bottom. My smallest amount is 2. Take away 2 from the top, I'm left with a 1. 3 take away 2 is just 1, or x. And that is on the, I'll write it here. That is on the bottom. Okay? We can write times if you want to, but we'll just put the times there for now. Okay? And then I've got 3 b's on top and 2 on the bottom. So I can take away 2 from the bottom, it's just a 1. So I'm going to have x times 1. And 3 b's on top, so 3 take away 2 is b. So I really had 1 times b, so 1 times b. And you can see I didn't actually have to write this because we just end up with b, because 1 times b is b, x times 1 is x. We end up with b over x, and that's our answer. Now we have a look at this one. Once again, we're doing the same thing. If you compare this question to this question, you can see how they are the same thing, except the fractions are written separately. Up here, the fractions, the x squared and the b cubed are all on the same line, the same vinculum. Whereas here, instead of being on the same line, they've put one multiplication sign and separated them. So we could have had this. We could have had a cubed, to find a cubed, times x squared over x to the power of 5 times a. These two things are the same thing, okay? And even then, we could also have these multiplication signs invisible and just have a cubed and x cubed on top and x to the power of 5 and a in the bottom. So just keep that in mind. It's just a different way of writing them, but we are doing and using the same skills. So for this one, simplify before we multiply. 3a's on top and 1 on the bottom. So take away my smallest amount, which is 1. 1a. 3 take away 1 is a to the power of 2. Okay, that's just a 1. 3x is on top and 5 on the bottom. Well, I can take away 3. That's my smallest amount. It becomes a 1. 5 take away 3 is x to the power of 2. And so my answer will be a squared times 1, which is a squared, over x squared times 1, which is x squared. I can't simplify anything else, and we're done. Now for D and E, I just realized my numbering is incorrect, so I'm doing it properly here. And I always do that, so I'm sorry. Now with these ones, D and E, you notice that we have, instead of variables, instead of letters like X and A, we have numbers. But we do the exact same thing. Numbers are also bases. So with this question, we can go 3 times 9 times 7 and 3 times 9 times 8, but we simplify before we multiply. And remember, this can be written like this. I could really have 3 over 3 times 9 over 9 times 7 over 8. These are all They can be written as individual fractions, same thing, except that they've joined it all on one fraction, on one line. So just remember, this is using your basic fraction skills. Now, I have a 3 on top and a 3 on the bottom. There's 1. And remember, these are all to the power of 1. So 1 3 on top, 1 on the bottom, we cross it off. Or here, we cross it off. 1 9 on top, 1 on the bottom. Cross them off. Now, I've got a 7 on top and an 8 on the bottom. I can't cancel them out, so my answer is 7 over 8. Because 1 times 1 is 7. 1 times 1 times 8 is 8. And we're done. So if we look down here, this is where it looks more tricky because we've got powers now, but we do the exact same thing. It's like instead of 3 squared, imagine I have x squared. Oops, sorry. Imagine I had, I'll just rub that out. Imagine I had x squared times, and 9 could be b squared, over 3 again, so x cubed times b squared. So that should have been b cubed. Imagine I had this. Instead of numbers, I could replace them for variables. So we do the exact same things. So here, if we've got 3 2's on top and 3 3's on the bottom, we can take away 2 and it's gone. 3 take away 2 is just a 3, or 3 to the power of 1, 1 3. And we've got 3 9's on top and 2 9's on the bottom. So the smallest amount is 2. So take away 2 9's, it's just gone, or a 1. 3 take away 2 leaves me with 1, or 9 to the power of 1. So my answer would be 1 times 9, which is 9, over 3 times 1, which is 3. And don't stop there. We know that 9 divided by 3 is simply 3. And that's our answer. So the last question from question 6 is this one here, and it's starting to look more challenging. But just remember, it's just the same thing as having all of this on one line and then all that on one line. These two fractions are separated by multiplication, so all we're going to do is simplify before we multiply. So I've got, we start with one thing at a time. You can get your vinculums ready if you want to. So I've got 2 x's on top. I don't have any on the bottom. So, and you notice that we have 4 x's here, but these x's and these x's are both on top. We can't simplify, so we'll just leave it for now. So x squared has to stay there, okay? I can't simplify with anything. And because I've dealt with it, I can cross it off. Now I've got 5 h's on top and 12 h's on the bottom. So I can simplify my h's. And notice I've also got a h down here and also 10 up here. So you can simplify whatever you want. That h to the power of 5 and that h and that 10 and that 12, your choice. But just do one thing at a time. So what I'll do, I've noticed I've got 5 on top here and 1 down there. So that can, I'll take out my smallest amount out of these two, which is 1. So h, so that's gone, and 5 take away 1 is just h to the power of 4. Before I write it down, I notice that I've got 12 down here and then 10 up there. So what I'll do next is get rid of this 4. I've got 4 h's up here, and I'll take away 4 from down here. And 12 take away 4 is 8. So now I end up with h to the power of 8. So don't get confused by what we're doing. This one is more challenging. It's a challenging question actually, because we've got h's now in all 4 areas. But do one thing at a time, and I can still keep going. I've got 10 h's up here and I've got 8 h's down there. So I can take away my smallest amount, which is 8, and 10 take away 8 is just 2. And finally, I end up with h squared on top. So I'll just write it on this side. So after all of that, we ended up with no h's here, none down there, none here, and 2 up there. Now what we have next is k on top. Do we have any k's on the bottom? Yes, we do. Now, another way to do this is, or what you could think about is, if I've got 1k up here, none on this side, that means all together on top, if I was to multiply it out, I've got 1k. Down here, if I was to multiply my bottom, I'd have 3 plus 8 k's, and 3 plus 8 is 11. So 1k on top and 11 on the bottom, I'll end up with leftovers on the bottom. So now, take away 1 from the top. You can pick where you want to take away that 1, from here or here. I'll just stick with this. this side. So take away 1 from there and take away 1 from there. I end up with k squared, and that's on the bottom. And make sure you cross off as you go, because you can see it does get messy and you might forget what you've actually done. And I can see what's left. I haven't crossed off my c's yet, so that can be next. I've got 12 c's on top and c to the power of 4 up here. So I can take away my smallest amount, which is 4. That becomes a 1. And 12 take away 4 is c to the power of 8. And that's on the bottom. I still have the extra power of 4 here. I forgot to write it down before, so I'll do that now. And that's on top. Now I can cross it off. And now I've got, let's see, a g on the bottom on this side and a k to the power of 8 left on this side. So cross them off as you go. And you can see that we have now written our leftovers. And it's important to make sure if they're on top, they stay on top. And if they're on the bottom, they stay on the bottom. And now what we do is we multiply everything out. So get your one vinculum ready now. And this is where you have to be careful, because if you have the same base on top, you'll have to add their powers. So I'll just change my color. I can see x squared times h squared won't change, but x squared times x to the power of 4, same bases. So what I'm going to do is get my bases ready. On top I've got an x and a h. On the bottom, I've got the C, I've got a K, and I've got a G. So our answer will look something like this. You can get your bases ready, and now add the powers of the same base. So 2 plus that 4, I'll have 8, so x to the power of 8. H, there's no h's on this side, so it's just going to stay h squared. I've got 8 c's on this side, none on this side, so c is just going to be to the power of 8. But k, I've got 2 k's here and 8 there. And because I'm multiplying, we add their powers. 2 plus 8 is 10. And g, no g's on this side, and it stays like that. And that is your final answer. So like I said, this one was a more challenging question. So if it did confuse you, it's okay. But just remember, simplify anything from the top and bottom, multiply it out, add the powers of the same base, and you're done. Now, with the challenge section, really question 6, you could have said 6D was sort of more challenging, but just keep practicing and you should be able to do these, no problem. So with these ones, you notice that they're just harder because with this one, we have fraction, an algebraic fraction, and then we have a power outside. But we're just using the same index laws and then simplifying. So we'll start with one at a time. So for 7, what you see, it's just different because, like I said, we've got a big bracket around the top and the bottom. It's very important that we recognize that, and the power 3. So just using, remember your BIDMAS skills or BODMAS skills, you have to get rid of the brackets first and also, take care of powers. They're the first 2 things you have to do. So that's what I'm going to do. And to do this, all you have to do, just like before, is circle that 3, and it gets multiplied with every power inside the bracket. And that includes everything on top and everything on the bottom. So I'm not going to do arrow. I'll do some arrows because it'll start looking a bit messy. There's a J down there and one more and an I squared there. Now it does look messy, so you don't have to do arrows if you don't want to, but I do it to emphasize that everything gets a turn and we have to multiply. So now all you're going to have is 3 is to the power of 1, and 1 times 3 is 3. So I have 3 to the power of 3. If you wanted to, you could get your bases ready. So I've got an I on top and a J on top, an I on the bottom, a J on the bottom, and a K on the bottom. So all my bases are ready, and now I'm multiplying the powers with 3. So I has got 3 times 3 is 9. J has 2 times 3, which is 6. I has 2 times 3, which is 6. J is to the power of 1 because it's invisible. So I've got 1 times 3 is 3. And K is 4 times 3, which is 12. And now we know how to do this. Okay, all we have to do now is simplify the same bases and we're done. Now, of course, 3 to the power of 3, I know I can work that out. 3 times 3 is 9. 9 times 3 is 27. So I can evaluate this, which means to write the actual number. I've got 27. I've got, sorry, that came out really crooked. I've got no numbers on the bottom to simplify with the 27. So it's even worse. But anyway, so 27 just stays on top and we're done. Okay. And now we simplify the same bases. So I've got 6 i's on top and 9 i's on the bottom. So I can take away my smallest amount, which is 6, becomes a 1. And 9 take away 6 is 3. So I've got I to the power of 3 and it's sitting on top. My j's, I've got 6 j's on top and 3 in the bottom. My smallest amount is 3, so take away 3 j's from the bottom. 6 take away 3 is 3, and I've got 3 j's on top. So that's a j, that's an I. And now I've got 12 k's on the bottom. You notice that we have no k's on top, so I can't simplify my k. So my k to the power of 12 is stuck on the bottom, and that's our final answer. There is nothing else we can do. Just remember, that's an I and that's a j. They're two different variables, so we can't add their powers. So that's it. Now for question 7b, remember this multiplication, these symbols can be invisible and we could have had just one big thing on top and bottom. But we don't have that, so we first of all simplify before we multiply. If you have gone, for example, 20 times 4 to give you 80, and then x to the power of 4 times x to the power of 4 times x and added their powers, you could do it that way, but it's important that you know and you can show your teacher that you can simplify fractions before you multiply them. So I'd like you to do it this way. So start off with one thing at a time. My numbers, I've got 20 on top, and then 30 and 12, and then there's a 4 there. So do just one thing at a time. 20 and 30, I know I can just chop their zeros off or divide them by 10. So now I've got a 2 there and a 3 there. 3 and 4 I can't simplify, but 4 and 12 I can divide 4 by 4 to give me 1, and 12 divided by 4 is 3. And I can't do anything else. Now, we'll keep going. If you want to start writing it out, you can, but this time I'm just going to cross off everything and then write it out. But just be careful, if it gets messy, then you can write it out as well as you go. 4 x's on top, just have a look. Do I have any x's anywhere on the bottom? No, so I can't simplify any x's on the top, they all stay there. Try h. I've got 5 h's on top, and have a look, I've got 1 down here. I also have 12 over here and 1 there. But like I said, just do one thing at a time, and I'll just stick with this side. So h to the power of 5, and h, the smallest amount is that 1h. So take away 1, 5 take away 1 is h to the power of 4. But I'm not going to stop there because I've got 4 h's now here and 12 down there. So my smallest amount is 4. So take away 4 from there, it becomes a 1. 12 take away 4 is h to the power of 8. And that's what I'm left with. But if you have a look, we've got 8 h's now on the bottom, and we still have this one here. So I can do one more thing with my h's. Take away 1 from the top, my smallest amount, it becomes a 1. And 8 take away 1, I have h to the power of 7. Alright, so the h's are all taken care of. I ended up with just 7 on the bottom. So it does get messy, but just try and write it clearly. Alright, so I've done with my x's, they're all on top still. Alright, now my k, I've got 1k here, and no more on top on this side, but I've got 5k's down there, and also 8 there. So you can simplify this k with these k's here, or that k with these k's there. To make things just simple, we'll just stick to this side. Take away 1 from there, I've got 1, and 5 take away 1 is k to the power of 4. So I'm left with 4k's down there, and those 8k's just stay there. We can't simplify them. And no more k's on top. So next variable I can work with is my c's. I've got 4 c's up here. So only 4 on top in total. On the bottom, I've got 12 here and no more. So 4 is my smallest amount. So I take away 4 from the top, it becomes a 1. And 12 take away 4 is c to the power of 8. X's I've taken care of. And now g's. I've got 5 g's on top, and that's all. On the bottom, I've got a g here and a g squared there. So I can take away, I've got more on top, so I'll take away I'll just stick with this side here. So I'll take away 2 from there. 5 take away 2 is g to the power of 3. But I can do one more thing, because I've got that 1g here and 3 on top now. Take away 1 from there, and 3 take away 1 is g squared. Oops, it looks like a Z. It's G squared. And now I have taken care of all of my variables. I'll do it down here to have more space. And like I said, it does look messy. So if you want to write this as you go, you can as well. And now we just write down whatever leftovers we have. So I've got x to the power of 4, that's not crossed off. That's times 1, nothing else here. On the bottom, I've got c to the power of 8 and x to the power of 4. And remember, everything else is just 1, so I don't have to worry about it. I've got up here now 1 times x to the power of 4, so it's x to the power of 4. On the bottom, I've got, don't forget that k to the power of 8 is just there. It's trying to hide from us. And I'm left with here h to the power of 7. That was my leftover. Up here now, I've got 1 times, there's an x here. It looks like it's hidden, so just be careful. So I've got an x, and I also have g squared. That was my leftover. So g squared. And down below that, I've got a 3 times 1, which is just 3. Okay, and just double check to make sure you haven't forgotten anything. And I'll just do that. I've got x to the power of 4, my x to the power of 8. Yeah, it's all there. And now multiply it out. Now we're multiplying it out. Just please be careful. We multiply numerators with each other. And if you have a look, we have x to the power of 4 times x to the power of 4 times x. When we multiply the same bases, we have to add their powers. So we can get our vinculum ready. You can get your bases ready on top. I'm going to have an x's on top. I'm going to have g, no more other letters or variables. On the bottom, I've got C, I've got K's, and a H, and a 3. And if I have a look, I've got 1 times 3, so my 3 can just sit out there. So that will be my final answer. And now add the powers of the same base, if there are any. And so back to this, I've got 4 plus 1, which is x to the power of 9. Then I've got g squared, no more g's on top, so it just stays g squared. I've got 8 c's on the bottom, and k, I've got 4 plus 8, which is 12, and h, I've got 7. That doesn't change, and that's your final answer, and that's an 8 there. Okay? And just remember, like I said, if you wanted to multiply everything out and add the powers of the same base, and then simplify, you can actually do it that way. But like I said, it's a skill to know how to simplify before you multiply. Okay, our second last question for this session, question 8. And if you have a look, we can see the brackets. So our first step is to get rid of our brackets using that index law, where if you've got a power outside the bracket, you multiply it with every power in the brackets. So if you have a look at this side here, these two brackets have been separated. There's a 2 here and a 3, whereas this one, both 3j and 4k have a big bracket around them and a 3 out there. So they all get a turn to be multiplied with the 3. So we'll start from this side. So remember, 2 times the 3, I will have k to the power of 6 on top. 3 times that 1 that's invisible next to the j and also the k, I will have j to the power of 3 and k to the power of 3 times, and here this 3 gets a turn to be multiplied with that one, and that one, and that one. If there's no power visible, everything has a power 1. So I'll end up with 1 times 3, which is 3, so 3 to the power of 3, 1 times 3, so j to the power of 3, 4 to the power of 3, and k to the power of 3. Okay, so that's all we've done, and now our brackets are gone. My next step is to simplify before I multiply. So I've got 6k's on top, I've got 3 down here and 3 down there. I can see I'll just be crossing them all off, because take away 3 from there, 6 take away 3 is going to be k to the power of 3. 3 there and 3 down there, gone, gone, my k's are gone. It's become a 1. And if I look here, I've got j to the power of 3 and j to the power of 3 down here, and I can just cross them off. So I can see my answer is now going to be left with some numbers. So I've got, remember there's all 1s here, so 1 times 3 cubed is just 3 cubed, over 1 times 4 cubed is just 4 cubed. And because these powers aren't big numbers, aren't big powers, I know that 3 to the power of 3 is 9. Oh, sorry, 3 to the power of 3, I'll just cross that out. It wasn't. If it was 3 squared, it would be 9. But 3 cubed is saying 3 times 3, which is 9, and 9 times 3 is 27, over 4 times 4, where are we, is 16, and 16 times 4 is 64. And that's our answer. There's nothing else that we can simplify with 27 and 64. Just check that, and that's it. And our last question for this session is 8b. And once again, the first thing I will do is get rid of my brackets. Don't start simplifying, just remove your brackets and then simplify. Now you notice this 100 is not in the brackets here, so it is not going to be times with that power 2. So we know that index law, okay? Let's find the equal sign. Okay, so we can get our vinculum ready. Sorry, it just kept freezing. All right, so my 100 will be staying there. It's not in the brackets. But now I've got 2 times 3 times the 1. So I will end up with k to the power of 2 times 3 is 6, and 1 times 2 is 2 for my b. On the bottom, everything's in the brackets, so I'm going to have, you can get your bases ready first if you want to, j, k, and x. So I will have 3 times 3, which is 9, 5 times 3, which is 15, and 1 times 3, which is 3. On this side, I have everything in the brackets as well, so there's a 1 there, so I can get my bases ready, k, b, and c, and now multiply their powers. So 1 times 3 is 3, 2 times 3 is 6, and that 1 times 3 is 3. On the bottom, I will have 10, b, and x. They're all in the brackets. That 10 has an invisible power 1, so 1 times 2 is 2, 2 times 2 is 4, and that 1 times 2 is 2. Sorry, that's a b over there. Looks funny. All right, and now that my brackets are gone, I simplify before I multiply. Now, just remember, that 10 squared, I evaluate it, and it is 100. 10 times 10 is 100. So just do that, and you can see why that's important, because I've got 100 on top, 100 on the bottom, cancel out, and they're gone. That's my first thing that's gone. 100 divided by 100 is 1. Now I've got 6 k's on top, and then there's 3 on this side. Do I have any k's on the bottom? Yes, I've got 15. So I'll work with these two. Take away my smallest amount, which is 6. So take away 6 from there. And 15 take away 6 is 9. So we've got 9 left down here. So k to the power of 9. And that's just a 1. Now, don't stop there. Still work on our k's. Because I've got 9 k's on the bottom now and 3 k's on top, out of these two, my smallest amount is 3. So take away 3 from there, it's just a 1. 9 take away 3 leaves me with k to the power of 6, and I'm finally done with my k's. Next, I've got b's on top, so b squared, 6b's there. Any b's on the bottom? Yes, I've got 4. So I'll just stick to this side. I've got 4 b's here and 6 b's there, so the smallest amount is 4, it's gone. 6 take away 4 is b squared. Next, I've got C's. Do I have any C's on the bottom? No. Is there anything else I can simplify? I've got 9 J's here. There are no J's on top. My X's just are both on the bottom. So that's it. So now let's write out what we have left over and then multiply them out. Oops, sorry. I'll fix that one. It's a bit bad. All right. So I've got on top, just be careful when doing this, I've got b squared up here. It stays on the same on its side and on top. And 1 times b squared is b squared. On the bottom, I've got j to the power of 9 that I see I haven't crossed off. I've got k to the power of 6, that was my leftover. And I've got x cubed that I haven't touched because there was no x's on top. That's done. This side, just check, I've got b squared and c cubed. And that was just a 1 there, so I've got x squared here. And our final step is I should just be able to squeeze it on the bottom. I'll change my color just so it doesn't look too squishy and messy. Multiply the numerators, this side times that side. And of course, you add the powers of the same base. Don't forget that. So we'll end up with, you can write your bases first. I've got a B on top, a B's on top and a C. Now, I've got 2 I've got b squared times b squared. Because we are now multiplying, add the powers of the same base. So I've got b to the power of 4 and c to the power of 3. There are no c's on this side, and I'm done. And on the bottom, I should just be able to squeeze it in. It's a bit small, but I'll try. I've got 9 j's here, none on this side, so I've got j to the power of 9 and k to the power of 6. No k's on this side, so it stays k to the power of 6. And I've got an x, but I've got 3 x's on this side and 2 x's on that side, so 3 plus 2 is 5. And that is your final answer. Okay, it looks hard, I guess, but if you just keep practicing, it's simply using the index laws that you know and working your way through it step by step. So thank you, and just let your teacher know if you have any problems.